Hello there, it's Jay here from Jay's Vintage Junk, and today I've got a couple of old 360k double density disk drives here, and I need a good working reliable disk drive to use with the Greaseweazle we saw when I was playing about with it in that previous video. The drive I had, I did actually get it working and it was reading off an old floppy disk, but the drive I had was only a single-sided floppy drive. It only has one head, which is alright for some applications. You know, I was reading Apple II discs or C64 discs or something like that. That wouldn't really be a major problem, and the Greaseweazle's absolutely fine with it. But there's sometimes when I want to be able to read perhaps an old PC floppy disk or something else that uses a double-sided double density disk. So really I need a proper double-sided double density disk drive. I'm not going to bother too much with high density in this application, because I have other computers and other drives and what have you for high density driving, which I can use when I need that. This is more for double density formats and the older stuff. What I really want to do is take a 3.5 inch, that'll probably be a 1.44 meg 3.5 inch disc, a 360k double density disk drive, and mount them in a case with the Greaseweazle, and just have a USB cable coming out the back so I can actually plug it into whatever laptop I want to use it with at the time, or whatever computer. And I've got it as like a standalone solution really. So what I thought we'd do in this video, like I said, I fished these two out of the attic. These come from a lot that I bought off a trader quite some years ago now. I bought a great big box of 5.25 inch floppy drives, and they're all ones that he tested and couldn't get working. So these have all got a fault with them. So like I said, I dug two out, and as it happens, I weren't really intending, but as it happens, these are actually identical drives. They're both the same make and model, even though they look slightly different. So like I said, what I thought we'd do in this video is have a look at these, see if we can get them actually working again. I've got my compact 486 out here. I've got image disc on that. I've got a screen set up and what have you, so we can have a quick look over them, see what they're actually doing when we connect them to a computer, and then see if we can actually get them into working drives again. So I'll get the camera set up so you can see actually the drives a little bit better, and we'll take a look what we've got. So back in a sec. Okay, here we go. In fact, let's see if I can perhaps just zoom you in a little touch there. There we are. So both these drives are, I believe they're Matsushita. Yeah, they are. They're Matsushita. I think that's how you pronounce it. Anyway, and they are the FMDO1710B4. Both exactly the same drive. I have a feeling these actually probably came out of something like the Amstrad 1512 or 1640, PC 1512 or 1640. They tended to use drives like these. I mean, that one I'm not so sure about with the actual colour of it, but that one, I'm fairly certain that probably came out of an Amstrad originally. A lot of these drives did get culled out of Amstrad. I mean, I remember pulling drives out of Amstrads when I took them for trading back in the late 90s, and just sort of just keep the drives because they might be useful, and the rest of the computers unfortunately went in the skip. I just wish I'd saved some more of that stuff that I had back then. But anyway, what we've got on here, we've got one, and the chap obviously when he was testing them, he has scribbled some points on here. So this one we've got, it says dirty heads ? So I presume that was basically just not reading discs, and hopefully it is as simple as just dirty heads. As though, to be honest, if it's gone through a trader, you'd think they'd probably try and actually clean the heads before they just condemn it as a faulty drive. This one, what we've got on here, we've got it's a bit worn off, but it says runs, no reading, and then we've got a damn capacitor. I presume that's referring to a damaged capacitor, and I assume that's referring to that there. There's a capacitor which has been ripped up off the board somewhat there. So with that, with the fact that this one's actually got some physical damage on it, which we'll need to do something, yeah, because I could possibly try it with that capacitor and it might still be just about making contact. It could also be short, to be fair. It's basically one of the legs has actually been ripped out of the capacitor. I won't try it because it could have actually shorted the capacitor internally. That. Take a look at this one first then, because this is just telling us it's got dirty heads. Let's take the plate off and we'll just have a quick look. Hopefully I can get these screws out. Oh yeah, that's come out. Excuse me. Hopefully I can get these screws out because of those Japanese heads that are they look like a Phillips, but they're not a Phillips. But you can usually get away with it and get them out. The heads look to at least be intact. To be honest, they don't really look that dirty, to be fair. I suppose we could, just seeing we've got the cover off there, we may as well give them a clean while we're in here. My Q-tips. I've got some IPA here. Because it only takes a second to do, and then seeing we've already got that top cover off, we may as well give the heads a quick clean. I can't really see anything coming off there, but no, there isn't a mark there. I thought there was. It was just a shadow from the yeah, that looks pretty good. Let's do the top one as well. Top one's always the harder head to clean because it's you can't really see it. You just got to be careful. It has more suspension on it than the bottom head as well. So you have to be super careful you're not too rough with it and damage it or rip it off. Again, let's give them a quick dry with that. Nothing's really come off there. The rest of it doesn't look in bad condition. I think what we'll do, we'll connect it up to the PC. We'll actually see what it's actually doing. So I'll get it connected up to the PC and I'll get you down on the screen and we'll fire it up and actually see whether it is even capable of reading a disc or whether the dirty heads was right or what's actually going on with it. So back in a sec. Right, okay, I think we're all fairly set up to try this now. I've got us set up. Basically what I've done, I've put a piece of board on top of the Compact 486. I've had to swap out the floppy drive cable because the actual one that was in the Compact 486 doesn't have the edge connector on it for 5 1/4. So I got one out of my stores and I've connected that up. And I've already been into the setup on the BIOS and I've set drive A as a 360k floppy drive rather than the 1.44 meg floppy drive. If you don't do that, then it'll come up in error on boot up on post. So you have to make sure the BIOS on the computer is actually set correctly for whatever drive you're working on, whether it being a 1.44 meg, a 360k, a 1.2k, or a 720k. You've got to make sure the BIOS is actually set right for the drive, or else you're gonna hit a hurdle straight away. So that's been done. We'll switch on. Already, that was quite an aggressive noise come from that floppy drive then. Now we won't try and boot from the drive or anything, we'll just see whether it'll actually recognise. Because I mean, some don't. Sometimes you can get a floppy drive that's faulty, and I don't think I've actually got one round here, but it won't actually even recognise on the computer. Just escape. Oh, it does have rather a ridiculous amount of memory in this computer for 486. That didn't sound very healthy at all on that floppy drive, did it? But it has. It's seeking there. It's seeing the floppy drive as what it is. And there we go. Right. We've got a C prompt up there. Just for interest, I'm just going to stick a known good, but it doesn't really matter if it gets wrecked. DOS formatted floppy disk in there. That's also good. Also far so good. Let's try going to A drive and see if it'll read it. And we've just got a general failure reading drive A. Abort, retry, or fail. We'll give a quick retry, but I don't think it'll do anything. No. We'll abort that out. What we can do now, we will go back to drive C and we'll load image disk up. So that's CD, IMD, and then we just type in IMD. And I'm sure you've seen me use this software before. It's what I use to create disk images for my 380Z CPM computer, things like that. It's a really useful piece of software. But it, as well as what it's actually intended for, which is creating disk images and recreating disk images, it also has some functions which are quite handy when you're messing with floppy disk drives. So if we look down here, we've got a test for RPM, we've got an alignment test, clean head, which is useful if you've got one of them disk cleaning disks. It's also useful if you want to just make sure that the disk is actuating, the head is actually actuating properly up and down the disk. Let's try test RPM and see, because this is a double density drive, so this should be running at 300 RPM if I'm correct. I believe it's a high density drive runs at 360 RPM. And the double density drive runs at 300 RPM. So let's just make sure that this is actually going to work. It's not actually able to run the test by the look of it. It hasn't brought us any data up. Let's try the alignment test, see if that does anything. Now we know we've got a good disk in here, so press enter to proceed. Now it should be giving us values down here, and we're just getting question marks. So it's not being able to read any of the data off the actual disk. Let's hit exit to escape, otherwise it'll just time out after a minute. Let's just hit the clean head, because I'm curious to see whether this can actually move its head correctly. So let's hit that, let's hit C. Number of passes, we only want one pass. And let's press enter, and then let's press enter again. Now that's not right. That should be bringing the heads all the way down here and then all the way back. So I think we've probably got something wrong with the head. It could just be as simple as we've got stuck grease in the heads. So what we'll do, we'll shut the computer down, we'll get back on the desk, and we will have a strip down and a clean of this disk drive and see if that's going to make any difference. So back in a sec. Right, I've got you down so you can actually see the disk drive here. And I'm just having a quick look at it, and first thing I want to try, if I just put my finger on the worm drive there, which moves the head backwards and forwards, and just see if I can just turn it with my finger. And we've got no movement there at all, really. So is that going to be our issue? Have we just got a stuck head? See if I can use a screwdriver and just wind. You can move it if you put a screwdriver on the back of the stepper motor there and push it round, but it is very, very, very stiff indeed. It should not be that stiff to move. I think that's where our issue is. So what I'm going to do, we'll do a little bit of disassembly. We'll get the main PCB out of the way so we can actually get in there, and we're going to have to clean all the runners, clean all the old grease off the worm drive off the stepper motor, and basically just do a little bit of a re-clean and a lube in there, and I think that might actually be the issue. We could have a bad stepper motor, that's another issue. It could be that one of the phasers on the stepper motor is bad. Unfortunately, I have seen that on drives in the past. How do you come out? Does that pull straight up by the look of it? Let's get all the connections. We can easily see how they come out. Try not to pull on the wires wherever possible, because you risk actually damaging the connector. In fact, the best thing I can do, get a flat blade like that, just get it in there and just use that to ease the connector out if it's going to be a bit stiff like that one was. Far better doing that than pulling on it and risk actually damaging the connector. That does pull out like that, but it's just, again, it's a little bit on the stiff side. So using a screwdriver just to help, just to get them connectors out, like I said, you're going to do less risk of actually damaging the wiring, because it is just crimp pushed in with a crimp there. It's not actually like a full connector. They're really cheap connectors, those. That is the LED from the front. I think that should pull off. At least you'd hope it would. Right, so how do we get that out? That's soldered on there. Perhaps we'll just have to push that off to one side, because we can get everything else out. There we go, that's off. Fortunately, everything is keyed and everything is easy to put back where it actually came from. So I don't want to risk damaging that. I'll probably leave that connected and we'll just swing the board out of the way to work on the stepper and the head. Okay, there we go, that's free. Get that out of the way and we'll swing that up and out of the way. have a quick look on the back, make sure there's nothing untowry on the back. Looks like there has been some rework done on this, around those connectors there, unless they were just very careless on cleaning the flux off when it was actually done. But there's definitely flux residue around a few components there that there isn't. Yeah, they're around the connectors there, and that looks a little bit skew, as though it's not been put on very well. And there's definitely rework been done around those solder points there. So I'll look at that as well, just make sure that's all a-okay. We'll swing that off now, and we'll take more attention to this stepper motor here. Oh, well, that's not good. The entire stepper motor. Look at that. That's not right. Now there's a little. It's as though the screws are missing from it. Because as I turn that, that's actually moving the. What I think we're going to have to do. That's definitely not good. What I think we're going to have to do is take a look at the other floppy drive we've got here, and just see how that motor is set. So it's set with the wires coming out at and it doesn't have any screws or anything holding it in position by the look of it. So how on earth has that come loose? Because it looks like that is meant to be like a press fit. That's the position it's meant to be in there. And it's like that's meant to be a press fit actually in there as part of that. So has this been dropped and that's literally just bashed itself free from where it should be? Oh, that's not good. That could be the end of this. It could be the end of this disk drive actually. Oh, that was the top of the compact 486 going over. Oops, pardon about that. I wonder. See, I would have expected there'd be some screws to hold this in there, but it's not. It's just a push fit. That's crazy. Well, now that's push fit actually back on where it was. And the head now actually moves. Yeah. Look at that. That moves now. In fact, even the grease doesn't feel that bad. Does it come all the way back to where it should go? Yeah. It goes back to 0. And it's moving absolutely, it's actually moving quite smoothly, that. Right, okay. So how do we secure that motor? I wonder, could I just literally use a little bit of super glue? Just like drizzle a tiny little bit of super glue down there just to bond it in place. Just bear with me a second, folks. Let me have a quick think about this. Okay, well, I don't know whether it's going to be any good or not, but I basically just got a little bit of that on the end of a cocktail stick, a tiniest drop I could, and just dropped a tiny little drop down there, give it a few minutes. Unfortunately, it doesn't seem to have got flowed down where it's interfered with the actual mechanism. I'm just hoping that's going to be enough just to hold that actual stepper motor so it doesn't come back out, because as I say, it's just a press fit into that metal bushing at the end there. That metal bracket has just basically got the stepper pushed into it with one little locating lug down there, so it actually holds it in the correct place. So I'm just hoping that's going to actually do the job. Anyway, while we're in here, it'd be silly not to basically give this a bit of a clean up and put some fresh grease on it. So I think that's what we will do. We'll get some IPA and we'll give especially the runner even more so than the worm drive, because that worm drive didn't feel too bad. But we'll give it a clean off, and we'll give the runner on the other side a good clean off. Like that. Rightio. And where's my paintbrush? I'm sure I just got a paintbrush out before. Just bear with me a second, folks. I've just got to find a paintbrush and we'll be right back. Right, okay, we're back, and I've got one. I need to go and get another one. Unfortunately, this is my last one as well, so I'll have to go and get some more. These are just really cheap kiddies artist paintbrushes. I get like a pack of 10 of them for about £1 from the local handyman store, and they're handy for all sorts. You can basically treat them as disposable. That's what I do with them, really. If you want to touch in a bit on a radio or a computer case or something, or you're applying rust proof, or in the case like this where I want to apply some grease really sparingly, these are absolutely ideal. I've got some suitable grease here. We'll get a little bit on the end of the paintbrush, and then we can just apply. We don't want to put too much on. I see a lot of people, and they certainly over grease mechanisms in like disk drives and stuff, and all you're going to do is attract dust to stick to that grease and cause yourself problems in the future. Literally, it is a case of a little dabble do you, really. What we'll do, we'll move that stepper back down. Looks like there, I've got a little bit too much on there, really, and you just need to take some of that off. Spread it a little bit further down, spread a bit more on this side here. Just make sure it's really nice even coating, really. That's feeling nice. Spread a little bit where we couldn't get before, and again on the shaft there, just spread it out. We'll go back the other way with the head. Just make sure that we're really happy that that's nicely lubricated across the worm drive and that runner on the other side. Yeah, I'm happy with that. That's running nicely now. That's nicely lubricated. Now there are other places on these drives that can benefit from a little bit of lubrication. basically where you see these plastic cams where they push down, it doesn't do any harm just to put a little bit, and I do mean a tiny little bit of lubrication just where them cams run, just because you've got plastic on metal contacts, and it just helps you know, prolong the life of the drive. Really, you can go a much, you know, deeper into servicing a drive like this. I see some people completely strip them down, you know, entirely. But unless the drive is absolutely filthy, really, you're going to cause more harm than good. I mean, if the drive is really dirty, it's really all you can do is strip it down like that. But when it's like this, and it's quite clean, the front's a bit dirty, and there's a little bit of dust here and there, but it's not caked in dust. It's not got great big dust bunnies in it or anything. It's not bad at all, really, this one. Right, what we need to do now is basically reassemble all this, and then we can try it back in the computer. So I won't bore you with me putting all these wires back on, so we'll come back when I've got this reassembled and we can try it in the computer again. So back in a sec. Right, okay, I've got it all back together. Now I haven't bothered putting the cover back over the heads so we can actually see the heads, make sure that those are actually working okay. So let's we'll switch on. Let's see if there's any difference in the... Listen to that. Now that made a bit of a more healthy noise, didn't it? And there we go. Right, let's see if it'll just read what I think is a good DOS disk. I should really test this in another PC, but I think this one's okay. We're still not reading that. Let's fail that and let's go back to C. And let's try image disk again. Let's see if this has got any more luck with it. Right. Let's try testing RPM, see if that's made any difference on the RPM test. Again, that doesn't seem to be doing. Let's try the alignment test. No, we're still not getting any luck there. Let's have a quick look at the clean head, see if that will move the head correctly. Yeah, look at that now. So we've fixed one fault with the drive. It could be that the heads are just ridiculously out of alignment, but you'd expect it to see at least it attempting to read something. That's one of the problems with what's happened to it with that stepper motor being knocked out. But like I say, it does have a little locating tab, and I have connected it up the same as the locating tab. I think what we'll do, I'll shut the computer off. We'll set back up and we'll have a quick look at the other drive and see what that one's doing, and hopefully that one's not sustained any physical damage as well. So let me set the camera back up and we'll be back in a sec. Right, okay, so I've got you down on the second drive. I think the first thing, we'll pop that cover off first. But I think the first thing we need to do before we can really even look at powering this up is address that iffy capacitor there. Let's pop this cover off. And just get in there and, well, that feels better than the other one did already on the drive mode, on the stepper motor. We'll get this board out and then we can have a look at seeing what we can do about that capacitor. I mean, we could have got the meter out and just checked that there was no short there and powered it up, but obviously with a damaged capacitor like that, it's not going to work correctly anyway, so we really need to address it. Oops. Come back here. Where? There we are. And we'll have a look at the state of the heads. In fact, we'll have a look at the state of the heads now, because if those are knackered, there's not much point in going any further. Now, they both look in reasonable condition, and we'll give them a quick clean up after. Pull that off. Get that off. Get that off. Well, that's interesting to note on this drive as well. I'm pretty sure this has definitely been used in an Amstrad. Because if we look at the drive select jumpers there, it's actually selected for drive select 0. Or as this is marked 1 to 4. If it's marked 0 to 3, it's basically the same thing. If you're using it on a PC, it needs either to be on, in this case, drive select 2, but if it was a 0 to 3 drive selects, it need to be on 1. But as we have no 0 here and it's on 1, it needs to be moved over to 2 to actually work with a normal PC interface, because the Amstrads were a little bit different than a standard PC, and they actually adhered to the Stuttgart standard completely, as where IBM didn't. Right, that's straight again, so we can move. I'll do this now before I forget. I'll move that jumper over onto the next pin over like that. So this will now definitely work with a PC. Let's hope that's the only, apart from that and obviously the physical damage on that, the physical damage on that capacitor, that might actually be the only thing wrong with this one. As where the other one, obviously it's sustained some kind of impact to something to knock that stepper motor loose. And we've obviously got another fault on there as well, and to be honest, at the moment I need one of these drives working. Would be nice to get both working eventually, but for the moment, for getting the Greaseweazle set up in its case with its drives, I just need one of these 360k floppy drives to work. But what I might end up doing, if this is successful, is I might end up buying another Greaseweazle and having two setups, one a double density setup and one a high density setup, which would basically cover every real drive that I want to be able to work with. Right, okay, let's get that out of there. That's been bent up there, but I don't think that's actually going to cause an issue. Right, let's have a look at this capacitor. Now we need a 33 UF capacitor at 16 volts, I think. Right, I'll get this one off the board and we'll get a new capacitor to go on there. Right. Oh, the iron's warmed up, nice one. Just tin the iron up and we'll see if we can just pull this out. We should be able to. It's fairly easy with a two-legged device like this. We just heat it up on that pin. Let's try that one first. That one's going. There we go, that's out. That's on a ground plane, so we'll just try adding a little extra solder to that. Just clean my iron off. There we go, that flowed a bit better then. And we can perhaps just pull this capacitor out. There we go, out it comes. There we go, and there it is out. Put that away. Oh, we've left one of the legs behind there, so we'll just have to get that leg. That's what I was saying. This is the reason I didn't want to just fire it up with that capacitor. I mean, I suppose we could have pulled it off the board and tried firing it up, but then again we're running it then with a capacitor out, and that isn't necessarily just decoupling on a disk drive like this. It could be something to do with timing, because occasionally they do use capacitors in timing circuits on stuff like this. Let's see if we can get the rest of that leg out, and I think we'll have to dig the solder sucker out just to clean them holes up. There we go, that's out. Yeah, and we'll have to just we'll just have to clean those holes up now. Where's the there it is. The manual desolder sucker is going to be perfectly adequate for cleaning these up. So we'll just go in there, warm that up, clean these just clean these holes out. That one's done. The one on the ground plane's been a little bit more of a pain, but we'll get it. There we go, that got it. Lovely. Right, just bear with me a second, folks, and I will go and dig out I think it's 33 UF I need. Let me find that capacitor and we can find out. Where's he gone? Ah, there it is. And yes, it's 33 UF, 16 volts, so I will go and dig one of them out of stores, and I will be back in a sec. Right, unfortunately, try as I might, I haven't got any new 33 UF capacitors in stock. Not even in axial versions, so I had to go and have a hunt on some scrap boards. And I don't have any really thin flat ones like that, but I did manage to find a good. I've just tested it on the capacitance tester and it is showing up as 33 UF, but I've got a replacement there I've just salvaged off a board, so we're not going to be able to fit it upright like that because it's going to be too high, I think, but we should be able to fit it kind of flat down like that and it should work alright. What I will do is I'll dress the legs up. unfortunately it still has quite nice long legs on it. And I'll get the legs so they're going to be suitable for going in there really. That should do us. That hole's not quite unblocked, just bear with us a second folks. Right, okay, I've cleared that out. All I did was take a little carbide bit there. It's a tiny little one, about the same size as a component leg. Just put it in the hole and just cleared it out, because there was just a tiniest little bit of, you could actually see through the hole, but there was still a tiny little bit of solder there. And sometimes when it's like that, that's the absolute worst to get out. Anyway, I've cleared that out, so hopefully we can put the new capacitor, there we go, that's sat in now. Give that a little push over. That's going to work okay. Like I say, it's not ideal, but it will certainly work. We just need to get them legs to go through a tiny touch more. There we go. Let's have a look at that. Yeah, that's nice to solder. We'll solder those in place, and then we'll have a quick clean up while we're in here, and we'll reassemble it, and we'll see if we've got any more luck with this drive. Okay. That's the new capacitor soldered in place. Right, while we're in here, let's have a, that does feel a little bit stiff, but the stepper motor has not been shifted about. That's still nicely attached. We'll get some cotton buds. We'll clean that old grease off the stepper shaft and off the rail on the other side. And we'll give it a re-lube. And then we'll give it a try on the computer and see if we've made any progress. Okay, give that a quick dry, and we can put some nice fresh grease on there. Give that a clean. Obviously we'll do the head as well. Yeah, that's not bad. It actually moves quite freely even just by giving the old grease a clean off. We'll get in there, get any old muck off there. There we go. I'll get some fresh grease. And as before, we don't want to use too much, just a tiny little bit. And again, a little bit on the rod on the other side. We'll move that back that way. Put a little bit on the rod there. Not too much. Move that back. There we go. That's nicely coated now, so we've coated the rod and we've coated all the worm drive for the stepper there, so that should be okay. Little bits of polystyrene in this one. Right, what we will do, so it'll probably be easier before we put that board back on, we will get in there and we'll give the heads a, let's get that board off to one side. There's a little bit of muck and dirt in there we want to clean out. Use the back of that Q-tip we've just used. Let's get some of that dust that's on there off while we're in here. It's not too bad at all actually. A little bit of dust there that just needs to come off. We'll get a fresh Q-tip out and we'll give the heads a quick going over. And then we'll get this reassembled and we'll see if this one's got any more life in it than the other one. What I'm thinking with the other one is that basically it's just completely out of alignment by the fact that that stepper motor has actually been literally knocked off its perch. Not really much dirt come off that. I can get in here and clean the top head. Careful not to don't like how much that top head was moving around then. I have a horrible feeling that might have been knocked loose at some point. Give them a quick dry. Might be alright, it's not as though it's flopping in the wind or anything, it just seems to have a lot more movement on it than on the other drive. We'll give the bottom head a dry. Okay, there we go. Right, and I will get them bits of solder off there. I'll get the board back on the drive and we'll come back when we're ready to test it in the computer, so back in a sec. Right, well we're set up on the computer, so we'll switch on. Well, that's a good sign for one thing that it retracted the head there, so let's see what happens when the computer comes on. Escape that. So it's got 40 odd megabytes of RAM in this computer, which is a little bit overkill for a 486 really. Well, that sounded healthy there, we got a seek out of it. We'll let the computer boot up and we will stick a disk in and see if we have any more activity than we did on the other drive. Okay, let's try. Still got a general failure reading drive. In fact, I'm even wondering, is that disk okay? But let's try this. Let's go back to C colon. And let's try format A colon. So I mean that disk is nothing, it doesn't matter. Look at that. Ah. Invalid media, track 0, bad, disk unusable. Let's just try just in case something has actually happened to this disk since I last used it. Just bear with me a second, folks. And let me go and find some other disks. Right, okay. I've gone and dug up. Basically, it's an old PC Shareware magazine disc, and I did boot this on one of my other computers, and it definitely does work. And if we put it in the drive now, DIR, that's working. Let's just see if something will actually run off it. Let's see if something will actually run. I mean, this is for like 286 and XT kind of era computers, but it shows that the actual software's, the disk drive is working. Right, I think we have to control alt delete out of this, unfortunately, but does this mean that the other drive's actually working? It could actually mean that the other drive is indeed actually working. I've got some disks here which I don't think matter that we could try and format. So let's try that. Well, that drive is definitely reading okay. Let's see if we can format a disk on it. I don't even know if this disk is PC formatted actually. It might not be. It might be. Right, it's just a completely blank disk that. So let's try formatting that disk, shall we? In fact, let's try formatting it and sysing that disk. Disk unsuitable for system disk. Well, it does seem to be formatting it. Right, okay, unable to write boot, format terminated, format another. Now, so is there still something wrong with this drive, or is these just some rather old disks that I've got? One of the problems is, unfortunately, that disks are starting to basically just fail. Let's see if this one will format. We'll just do a straight format on it and see how that works. That seems to be working. And that seemed to work okay. Enter for none. And we've got no errors on that disk. 362.496 bytes total disk space, and we've got 362.496 bytes available on disk. Right, that's excellent. So we don't want to format another, no. Let's try and copy something onto that disk though. So let's try, this is actually going to be interesting, let's try copying something onto this disk. So what I'm going to try and copy onto it is image disk. So CD IMD. Then we'll go copy star to A colon. That seems to be working. There we go. So that's copied all that onto, to go to A there. DIR. We've got all the files actually saved onto the disk there. Let's go back to C. And let's run image disk. Right, and let's have a look at alignment test number 8 with this disk in. And if you remember before when we was messing about, we were just getting question marks. Let's see. There we go. That seems to be working quite nicely. Escape on that. Let's test RPM, see, because we weren't getting that to work before. There we are. It's really a tiny little bit high, but yeah, we're not far. We're just running it. I don't think that's bad actually. No, it's pretty much evened up here now. It's running around the 300 RPM. I say it was running a little bit high before when it was just getting ready, but that's bob on 300 RPM. So it's definitely double-sided, double density. It definitely seems to be working okay. I mean, a little bit of glitchiness like that, you're not too worried about. It's better if it's rock stable, but it's if it's fluctuating, or that's well off. You'll see if it was running at 320 RPM or something. Then, actually, believe it or not, actually, discs written on this drive would read on this drive, but if you tried reading them on another drive, they wouldn't work. Escape out of that. I'm just really curious, is the other drive actually dead, or was it just a dodgy disk? So what we'll do, we'll exit out of this, we'll shut down, take that disk out, and we'll swap back to the first drive. So I'm reasonably happy that that drive is now actually working. Plug this one back in. This could still be faulty. It could be that it is faulty, and it was just a case of, what have I done with that disc now? The disc was also faulty. Now what have I just done with that shareware disc that I loaded on this before? There it is. I mean, we've definitely made improvements with this drive, because when we started it was just making a horrible grunching noise. It wasn't actually moving its head properly, so at least we've addressed that. It's just whether there's anything we can do, you know, if the alignment's whacked right out now and there's no actual way of resetting the alignment, there's not a lot we can do really for this drive. It'll just be a parts drive, but it would be nice if we can actually get it working. Let's just try. Oh, look at that. Have we got 2 for 2? That seems to be reading. Let's try running the menu again. Well, that's working. Let's try and do something to actually give it a bit of something to actually do. Number 2, let's try and install something from this disk on this drive to the hard drive and see if that'll actually work. Unzip to hard drive. Let's do it. Install now on hard drive. Do you wish to continue? Yes. Right, we'll type C. I don't even know what the software is, so Batacom. So let's try type BATTO. I'm guessing it's some com software actually. Is this correct? Yes. And let's see whether it can actually read off this disk. Bear in mind this is a compressed. Whoa, that was fast. Because that was a compressed file. Pressing the key to continue. Right, let's exit to DOS. Let's go to C. And let's see, we'll go on into that directory and actually see whether it's actually installed something that is usable or it's just installed gibberish. So let's go cd batto. Let's have a look what's in here. Let's try it. I don't even know what it is. Like I say, I'm guessing it's some comm software or something like that. Oh, it's BAT to COM. Right, it converts BAT files to COM files, right. But anyway, you can see it works. It's actually unzipped it from the disk and it has installed it on the computer. Now let us try it, because that's a commercially written disc. It's a cover disc off PC Shareware magazine from December 1990. I've got a handful of them that I got from somewhere. Let's take that that disc from before. This is the one that we formatted and copied image disk onto, and let's see if this is going to read it. Remember, this was written on the first drive that we got working, this drive. So let us see whether it will read on the other drive. There we go, it reads. I'll try and start image disk off it, but sometimes image just does crash when you try and run it off the drive that you're actually running on, but let's try. Yeah, like I say, it doesn't always like running itself off the drive that it's actually on. I've come across that problem before. Let's ignore that. Fail. What we can do is we can run IDM now and we can just do the same tests we did on the other drive and just make sure that it's actually reading and we get the right RPM test and everything. Let's quickly do that. So again, we're back in here, so we'll do alignment test and see if we actually get some data coming down here rather than just question marks. There we go. I should really read all the documentation for image disk so I actually know exactly what all this is. Image disk is very powerful and it's got quite a large manual which I've got to print out and really digest. Although quite a few things that image disk does for me now I can actually do using the Greaseweazle. That's one of the reasons for actually getting the Greaseweazle set up, so I don't have to have that 486 set next to the 380Z just for really creating disks for that computer. I'll be able to do it all with the Greaseweazle. Right, we said we're going to do a test RPM, so let's just do that just to see. We saw what the other drive was like. This should be very, very similar. Yeah, it's not bad. Again, it's just off the three. It's like 300, just going to 301, 2, back to 1. It's pretty close, that. Right, let's Let's escape out of that. We'll escape out of that. We'll shut that down. We'll get you back down on the bench. There we go. Down you go. Let's get the two drives. Well, I thought we was only going to be getting one working drive out of this then, with having that iffy stepper motor. Can't say I've ever come across that before, where literally the stepper motor's been that badly bashed that it's actually knocks it free from a mounting like that. I'm slightly dismayed to see actually the stepper motor just being a push fit in that bracket rather than actually being screwed into place, but it is what it is, unfortunately. Right, what we will do, we will put dirty heads on that one. Where's that screwdriver gone? And we'll put damaged capacitor on that one. Oh, that damn cap. There's someone's marked on there. We'll take a little bit of IPA. And let's get rid of that dirty heads on there. Let's give that a quick wipe off there. Like that. We'll do the same with this one. We'll get the damn capacitor and the runs no reading discs. There we go. So we have two working floppy disk drives. That one, it needs a bit of cosmetic cleaning up. They both needed a little bit of cosmetic cleaning up on the fronts. I'm not going to show that in this video. There's plenty of people showing how to do the cosmetics on these things, and I'm not all that much about cosmetics really. I mean, obviously if something's really damaged, I'll do something about it, but I'm not. These things are, you know, 30 plus years old now. They are going to show a little bit of signs of wear and tear. There we go. We'll just give it a quick. Let's get some of that real nasty gunk off there that was on there. That's a little bit bashed up on the end, but again, I'm not that mithered about that. I'm more into them actually physically working. These aren't for any display computers or anything like that that's going to be on show. They're going to be used in working systems. In fact, what I'll probably end up doing is I'll probably end up putting one of these in my Amstrad 1512, PC 1512, because I've got a black one in there at the moment, and I'd rather have a matching one, so I'll decide whichever of them two is the nicer matching one and put that in my Amstrad 1512, and the other one of these will go together with a, like I said, a 3.5-inch floppy drive in a case, and be built in with the Greaseweazle, and that'll be a separate video I'm going to do on putting that unit together and really getting to grips with it. So yeah, I'm going to leave it there for now. I hope you enjoyed this little video on sorting these 2 floppy disk drives out. I said at one point I thought we was only going to get one worker out of the 2, but as luck would have it, it was just a bad disk, and indeed they both now seem to be working quite nicely. So I will say thanks for watching and goodbye.